Hello, folks. How's everybody? I hope everybody's doing fine. A little better than me. Yes, and this is Rational Science, directly from Frankfurt, Germany. And I just wanted to say that the reason I postponed Wednesday's class to today is that I was in the hospital. And I thought I had a mild heart attack. And they checked me out. They had me there for 6, 7 hours. And it turns out that I'm okay. I have no problem with my heart. I don't know why I would have problems with my heart because I run every day, jog half an hour almost every day. And they checked my blood, my pressure, everything was normal. They sent me back home. But it was a little scary. I had some kind of adrenaline flow near my heart and a woozy feeling, so I didn't know what it was. And talking about near death or being in limbo between life and death, today's subject matter is Schrodinger's cat. And it turns out that that was the subject I was coincidentally that I was going to talk about on Wednesday. So, well, I postponed it to today. But before I get into Schrodinger's good cat, we're going to play a little game. It's got to do with extinction, okay? And it's called the game of halves and have-nots. Okay, the game of the haves and have-nots. Looks something like this. Okay, that's the board. Okay, and what this is about is again the arrows just indicate time. For most of human history, we've been hunter-gatherers. Okay, you've heard me say that before, and I would say I put 90%, but I think we were hunter-gatherers for more than 90% of our time. And I judge the beginning of humankind as, if we go back in time today, who would be the last person we could still have viable sex with, in other words, reproductive sex, and that would probably be anywhere between 200 and 300,000 years ago. And so that would be my starting point for the species. Since then, 90% of the time, we have been hunter-gatherers. About maybe anywhere between 5 and 10,000 and maybe even 15,000 years ago, we went into agriculture, first subsistence agriculture, taking care of our own needs, and then eventually moving into commercial farming when we built the villages and started becoming more neighborly with our neighbors. Okay, I would say that maybe 9% of the time humans have been on Earth, again since 200 to 300,000 years ago, we've been in agriculture. That was the main mode of production. And as you can see, only 1% covers the rest. We were manufacturers maybe since the late 18th century. We could say that's when the Industrial Revolution started in some countries, okay, especially in Europe. And that lasted for quite a while until about, I would say, 1979, which is about the time when the Bretton Woods Accords were also signed, which is when we switched over to services. In other words, services in some of the most advanced nations became the primary mode of production, you could say. In other words, most people worked in service, more people worked in services than they worked in manufacturing and agriculture, and also GDP, a bigger percentage, more than 50%, started being services. And from there, we just increased services. Today, we've got almost maybe in some of the advanced countries, we have maybe 85% services, about 14% manufacturing, maybe 1% agriculture. That's how it's divided. But then, as I said the other day, we've got different kinds of services. And the services that's taken over in the last 10 years, I mean, we've had services now for 40 years, since about 1979, 1980, thereabouts. And about 10 years ago, a new trend started, and that's services that do not require hands. In other words, it used to be labor-intensive services, that's what I'm going to call it, and we started going into the information business. We're all getting on the internet, and we're leaving behind things like, landscaping, building roads maybe, barbering, fast food restaurant, any of those, you know. So we stopped doing, or we're phasing out things that require people, and we're moving into things that are more abstract, information, commercials, doing websites for ads, that sort of thing. Okay, and so this is the big picture. Okay, and why is this one pertinent? Well, here's what it's about. It's about trade. What can you trade? Well, as far as I'm concerned, there are essentially three things that you can trade. We can make it a little more complicated, have subcategories. You can buy land and sell it as well, that sort of thing. But these three essentially cover it all. This is the basics. This is the fundamentals, okay, here. And we have labor. You can trade labor. You can trade gadgets, things that have been processed, manufactured things that we make, okay, inventions, that sort of thing, tangible things which are not food. And then you have food, okay? So these are the three things you can trade. I'm going to call the people who have, remember this is the game of haves and have-nots, okay? The haves are the people who have gadgets and food, okay, who have control over gadgets and food. Not that you go out there and buy it. No, that's not control. Control means that you produce it, you distribute it. You know, you're in control of food, and you're in control of the televisions, the TV sets, the telephones, the cars, the ships, all that stuff. The people who actually own these things or manufacture these things, which they own it until they trade it. For what? For usually for money. Okay. And the have-nots, what do they offer? All they have is their labor. All they can do is trade their labor for something, okay? So that's the big picture, and here's just a little tic-tac-toe on that, okay? You can see how it is. You can trade food for food, food for gadget, food for labor, gadget for food, gadget for gadget, gadget for labor, and so on, okay? So all you got to do is put the X's there, and those are the different possibilities in the game I'm going to talk about today, okay? I hope you can follow along. Don't get lost. Okay. Okay, let's start with a little background here, or where I'm coming from with this trade thing. Okay. Here you have our beginnings. You could call it beginning. There was a beginning before this beginning, but it was the same. It was hunter-gathering. And I think it was like 99% hunting and maybe almost nothing gathering. Gathering probably started just maybe around the Neolithic or just slightly before that. I don't think there was that much gathering in the old days, you know, Paleolithic and so on. Okay, what's the family type? It's the clan. It's group sex, group reproduction. Everybody is fair game inside the cave. Okay, maybe someone elopes, gets out of the cave, finds a little girl out there who also eloped, and they formed a new clan. That's one way of doing it. There's different theories on that, okay? But essentially it was the clan, okay? People you trust. You don't trust the clan on the other side of the river. So Cro-Magnon, he did not trust the fellow on the other side. They were enemies, they were competitors, they had their own lands. The country was the clan, okay? And so was there any trade? Well, perhaps within the clan you can talk about trade. You know, there was a division of labor essentially, and you have the men who probably made their own tools and weapons, right? They hunted, they defended the clan, okay? That was their responsibility, that's what they did. And the women maybe, and this is again, maybe you'll accuse me of being too macho-centered, but this is the way I see it. I think women primarily stayed at home, primarily because, you know, they had children, they had to take care of the children, they reared them, right? And they probably cooked. When clothes came around, they probably helped make those garments while the men were out there. You know, I think a lot of that developed in those days. And that's just my guess. I don't have any proof for any of that, okay? That's just the way I imagine it, okay? And they probably did some gathering. Okay, so they probably gathered nuts while the men went out there and hunted some animal. Okay, food is the only real commodity. Okay, but within the clan, that's the only time you probably will see trade because there is no trust. No one trusts anyone in the jungle. Just ask any lion, does he trust his neighbor, the pride next door? No, they're enemies, they're competitors. In fact, the biggest enemy of a lion is another lion. Certainly it's not a cheetah or what is it, a fox or a small animal. You know, those are not enemies of the lion. The enemy of a lion is another lion. Okay, he's the king of the jungle, right? Okay. Then we continue. We go from the hunter-gatherer, and I'm stepping over a lot of steps here, okay, just jumping over them, okay. Family type goes to patriarchy, maybe in the days of the Greeks, which is what I'm illustrating there, okay. Obviously, there was this phase where we started doing farming, then again, subsistence to begin with. Maybe there was a mixture of hunting and agriculture, and then eventually it shifted more or less into agriculture and left hunter and gathering behind. Okay, we don't have any hunter gathering today almost. Okay, maybe some tribe out there still does it. In this society, this new arrangement, the master is the one he's the have. Okay, he is the one who controls not only the food, but the gadgets. He's the owner of the house, the land, he's the owner of everything, okay? And he also has power of life and death over his wife and children, okay? He had that kind of power. He was the man, okay? Long gone days. Okay, we formed the tribes, the villages, the cities. They evolved. We had these city-states, at least with the Greeks. Even before that, you had the Persians. They also had cities, big city, in fact, Persepolis. Trade develops because what? Now you trust, you form these villages, and somehow trust develops there, and because of trust, trade develops. You begin exchanging things. Maybe it was goods at first. Again, maybe it was good for good. In other words, gadget for gadget. Maybe it was gadget for food. And at some point in time, we started trading labor for food. One example I've given in the past is the story of Ruth. You can read it in the Bible. And Ruth worked for food. She traded her labor for barley. She was given this barley and she would take it home. In fact, she took it to her mother-in-law because she couldn't work apparently. And so her work served to maintain the two women. Okay? They were both widows. Okay, so we developed trade, we developed trust before we developed trade, right? And we began to trade everything, gadgets, food, labor, the whole works. Slave, he works for food, and you would say close to half the population in some places. In fact, I think in Sparta it was even bigger, the Helots. They were, I think they were a bigger population than the Spartans, but they were slaves, they worked the fields, and they were under control. But yeah, a slave works for food. He does exchange, but it's not a voluntary exchange. Okay? And we have the same or similar situation. This gradually changed over time. Feudalistic era, we have the serfs. And they don't have much of a choice either. They have to work for food. And part of that labor, in other words, part of the product of that labor, goes to maintain the Lord who protects them. You know, Joe will protect you. You need protection. Okay, and so the Lord is the one who is the have here, right? He's the one who has, and the serf, the vassal, he doesn't have really. He just in the case of the serf specifically, he donates his labor. He has another choice. Okay, that is his life. So again, it's not voluntary in this case, not free will. It's not free will when they put a gun to your head, or not someone, but life itself. You know, hunger puts a gun to your head. So that's not you know, very much free will. Okay, free. You're not entering into a contract there on your own volition, your own, you know. decision, essentially. Someone decides for you, and that's your stomach. Okay, we have incipient industry, we have the guilds, the craftsmen, the merchants. Okay, all these people start developing, maybe around 1200 onwards, even before that. I'm not going to go into the details on that, but essentially there is a transition. Okay, what's the next transition? Well, we move into manufacturing industry. You heard of the Industrial Revolution. And that was around maybe the late 1800s, late 18th century, 1700s and so on. That's when when some of the countries like England and France and Germany, they started coming up. They started creating all these machines that they invented. The machines replaced people in the farms. People from the farms had nowhere to go because they were no longer necessary in such numbers, so they came to the cities to work in the factories, and the factories produced machinery for the farms, and so that whole cycle pushed people from the country to the cities, and that's known as a transition. That transition is still ongoing today. Okay, most countries that has pretty much ended, at least in the advanced nations, but in the underdeveloped nations or the aspiring nations, that process is still going on. Okay. Farming begins the process of, in farming, you have the process of automation, and we have the transition from the country to the city. And the proletarian, what does he do? Well, he has to exchange labor for food, essentially. Again, not very free because the stomach compels you to do something. You can't just go in there and say, well, I'm not going to work, because then you starve, okay? Because society is built around work. And it is a contract between the owner, okay, of machinery and factories and so on. We'll call him the industrialist. See, it's a contract between the industrialist and the worker, but the worker doesn't have much of a choice but to sell his labor. That's all he has. He starts being deprived, essentially, of being the owner of goods. He's no longer a carpenter. He's no longer a blacksmith. He doesn't have a trade. He doesn't belong to a guild in that sense. In other words, he's just a worker who sells his labor for an income, and that income primarily, because he's at subsistence level, more or less, serves primarily to keep him alive till the end of the month, 2 weeks, until he gets his next salary. Okay, what's the next step? Okay, we go here, and that's we move, especially in the 20th century, we started moving into services. Services start taking over, muscling aside manufacturing. That transition takes place around in countries like Sweden, one of the countries I know it took place. The United States. Also around 1979, 1980, thereabouts, that's when services became a bigger percentage of labor and of GDP and started muscling manufacturing aside. Remember, after World War II, and in fact shortly before that, manufacturing just exploded in the world. They started inventing machines. We forget that washing machines did not exist in the 19th century. They really started in the 1940s, 1950s. That's when a lot of these inventions really became popular. The phone, the car, all that started to expand. And so manufacturing was expanding like crazy. And there was a lot of work in manufacturing. Well, that started changing after the 60s, and by the time you get to the late 70s, well, it's taken over by services. A lot of automation was introduced in the factories, and there was a lot of innovation in how things were done, and so, manufacturing didn't need as many people, so these people went into services. A lot of people opened their own shops, became middlemen, and they hired people, and so a lot of people went from being a factory worker to being maybe a cashier at a company, at a food outlet or whatever. Okay, so what happened? We have the service worker, but remember, the service worker is at this point still, okay, it's labor intensive. It's work that requires hands. You can do deliveries, you can do cashier, you can do barbering. There's a lot of work. It's service that you're doing, but it requires people. It still requires people. Okay, and again, you see the percentages there. Farming 1% today, more or less in advanced nations, maybe between 1 and 2%. Manufacturing anywhere between 15 and 20 for a lot of the advanced nations. Okay, and the rest is all services. Okay, so we're all doing services. Some people always say, "So what?" Okay, I'll try to address that. I don't have today, but I usually do. Okay, and this is today. We should maybe put it over here. Okay, this is today. Different type of service. Okay, it's internet worker. It's not the same types of service where you actually have to have hands-on when you use your hands. This is more abstract. It's an information world. Information meaning that what do we do? Well, what we do primarily is go on the internet. We create a site or whatever, and it's usually some website creation. For what purpose? For ads, commercials, that sort of thing. What, to sell things, and that's keeping people working. And so people are getting out of things where you need hands, services where you need hands, where it's labor intensive, and we're more into this information, into the leisure world, maybe for vacations, for things of that nature. And even that's dying, at least today with this COVID thing. Okay, so what happens now? We're doing action at a distance worker. Okay, we have this action at a distance. He doesn't have to go to the factory or to the office. You can do it from home. I think there's going to be a lot more of that. People doing websites or working on the internet. Lots of internet work. There's still demand for that, and if anything, that's rising. And what's falling behind is, a person going to the mall. Mall? What is that? What is a mall? I mean, the malls are going to die if we continue like this, and so are the restaurants and hotels, and people will just do all their stuff from home. Okay, so we're moving into a world in which it's an information society, information economy. Okay, and that's a little different than the services we had until now. Okay, so we have the rise of the internet entrepreneur. Okay, the guy puts a little channel and does something. He gets money for it for somehow. What for? For creating commercials, ads. It's all about ads. So we're all into the ad business, so to speak. And we're also in the leisure business. We try to entertain and so on. Okay, so that's where we're headed. Okay, some play the stock market, play Bitcoin. Okay, Bitcoin investor. We have the scam artists, Nigerian scams. The girls, they go online, they show whatever they have. Okay, that sort of thing. It's entertainment. It's leisure. Is that real work? Is that long-lasting work? I don't know. You tell me. Okay, so what's the deal? Here it is. These are my corollaries. Okay, this is what I get out of this. This is my take on this, by the way. Okay. Yesterday, the clans were the halves. Today, it's the corporations, which are the halves. What do I mean by that? They have the goods, the solid goods, the material goods, and they also have the food, because we don't produce food in our apartment and on our carpet. We don't grow potatoes. No, all that's done out there by farms, by specialists, people who work with machinery, and they work all these what would be called economies of scale. You have all these farmlands being farmed by airplanes and by big combines and so on. So they have these big operations. They produce food for everybody. So they are the controllers of food, and they are the controllers also of manufactured goods. Okay, we don't manufacture goods at home. Certainly a lot of people would not even be interested in doing that. They'd rather play piano, with the little keyboard, and let somebody else do that. Whoever does that, we don't know who does it. It just somehow magically brings the product to market. So the owners are someone else. Okay, someone else has become the owner, and in this case, the owners of all tangible goods. Okay, are corporations primarily. Okay? They're becoming, if they're not totally today, they are certainly becoming. Okay, and that's one of the issues here. They're pushing everybody out, even out of services, manual services, labor-intensive services, into the information world. Okay, okay. He who is his labor only has labor to trade. Trade is involuntary if it must be traded for food. Trade is involuntary if it must be traded for food. Subsistent wages is involuntary trade. Leads to that. That's what it equals. Most labor today is involuntary trade. Involuntary trade is the fastest growing segment of the global economy. And again, we have this transition from the country to the city. We're in the last phase of that. If you look at, just pick the country you want and just look at its history in the last 40 years, they've switched from manufacturing, and now they're into service mode. Just about every country in the world, most of its gross domestic product, and probably its labor as well, is now due to services. Okay, so the percentages of services are rising. What's being crushed out or being crowded out is manufacturing. And agriculture was crowded out a long time ago. Nobody does agriculture anymore. I mean, well, they still do, but I mean that's dying as well. Big corporations are taking over the small farms. Okay, and then urbanites, people in the cities, they rely more and more on subsistence wages. Okay, you have devaluation, you have real value. And again, which is being lost because again, when you devalue the coin or throw more money into the pool, suddenly they've reduced your wages. Okay, because that's what it means. Okay, more money in circulation means you suddenly your money is worth less, not worthless, but worth less. Okay. So what's the goal? The goal here is to tell me what's the next. That's the object of the game. Okay, what's the next service that you can imagine? We're not going back to manufacturing, so inventions are done. Whatever you invent is worthless, doesn't matter. Okay, all you can do is maybe make a minor change in something, cosmetic change, and so manufacturing really is not going to pick up again no matter what you invent. I don't care if you invent the machine that takes us through the fourth dimension. It's not going to put billions of people to work anymore, not in manufacturing, blue-collar workers. Okay, and agriculture is already on its way out. It's gone almost out completely in advanced nations, very small percentages again. And so we have services today, and these services are being crushed out in the direction, okay, of information. And the question is, okay, that's going to have its exponential curve now, maybe the last bit, maybe a few months, a few years, I don't know. And then it's going to reach an asymptote when, that is saturated. And the question is, what can you imagine? Talking about imagining now, smoke a pipe, whatever you need, take a beer, and just try to imagine, close your eyes, try to imagine what type of service we can invent next. What other subcategory of services you can imagine next, okay? That will put people to work. I mean, that's the point of this. The point is, we want to know where all the GDP and all the labor is going to be, 50 years from now, 100 years from now, okay? So try to imagine what the next services are, and that's the goal, okay? Again, this is part of the extinction theory or the extinction argument, and anyone who wants to address that has to go through Extinction 101 before he goes to Extinction 102. For me to answer. I mean, if they don't cover Extinction 101, I'm not even going to bother. Why? Because everybody's an expert in Extinction 102. In fact, everybody's an expert in human extinction, actually in how humans will not become extinct. They always tell me, no, Bill, you're wrong. That's not how humans will become extinct because of this, this, and this. Everybody knows how humans will not become extinct. What I'd like to see is someone who knows how humans will become extinct. That would be great, we need a foolproof mechanism for how humans will become extinct. If you don't have one, it means your argument will be that humans will live forever. And you might say, well, there's going to be a catastrophe. Well, yeah, maybe there will be and maybe there won't. That's not foolproof. Okay? Fool and foolproof, both. Okay? That's not a foolproof mechanism. I need a foolproof mechanism of extinction, something that will definitely necessarily kill man. And I'm not talking about the sun being blown up 5 billion years from now. No, I'm talking about maybe the next 100, 500, or 1,000 years. If that's what you think man is going to last. Okay? I'm saying he's going to die because of this, because of the economics. You think it's not the case? Fine. Then what you got to do is come up with a foolproof mechanism that will kill man. Something man can't do anything about. Something man can't do anything at all about. You can say, well, man can do anything about anything. Not so. I can tell you one thing for sure. Okay? Hand in the fire for this one. Man cannot have children. Okay? Humans cannot have children. Okay? Not anymore. Okay? So the population from now on will go, in other words, the growth, population growth will be asymptotic until it reaches a plateau, and then it'll start coming down. And the reason we can't have children is because of several reasons. Economics won't allow it. Culture has changed. City folk can't have 10 children in an apartment, etc., etc., etc. There are many reasons why we will not have children. Women don't want to have children. Men don't either, many of them. So now it's going to be sex for pleasure, recreational, not reproductive. Okay, we will not have children. The last time we had a high level of children was 1963. That's when we had like 2.1 growth, world, this is global, growth of population, and now we're down to 1. And if everything goes according to plans, by mid-century, if we reach that far, it's going to get down to 0 population growth. One person is born, one person dies. There will be no growth in population. Okay, and so we cannot have kids, essentially. Okay, women will not have kids. Money doesn't allow it. Apartment doesn't allow it. Culture doesn't allow it anymore. Okay, that's gone. No woman's going to have 10 kids. Okay, one maybe somewhere. That's gone. All our great grandmothers used to have 5, 10 kids, no problem. Half of them died, no problem either. Today we don't have kids. So yeah, there are things man can't do anything about, and one of them is having kids. Okay, kids are out. No, that'll never happen again. Okay, so that's the deal. Okay, you got to figure out what the next type of service will be. And here I have something here. See if I can find it. Ah, here it is. Here's the chart that summarizes more or less my argument. Okay, I'm saying that for over 200,000 years we were hunter-gatherers. Okay, and about 10,000 years ago, these numbers are, by the way, very very general. You don't have to put your hand in the fire for the numbers, okay? But these are just numbers to make my case. You can add or subtract thousands of years from them. Okay, so you have hunter-gathering over 200,000 years. Then you have farming, agriculture, for about 10,000 years, again, general. Maybe 200 to 300 years we did industry, okay? And you can see that agriculture started dropping as manufacturing increased there, the green versus the blue, okay, where it says 200 years. Okay, so manufacturing starts rising, agriculture starts dying, and I didn't take it all the way down, but you can see the trend. Agriculture is going down all the way to our days. Today it's a very small percentage. And again, that percentage is still high because there are other countries that are still doing agriculture. That's why that that bar is still big. Okay, but essentially what we see is that both agriculture and manufacturing have been pushed aside by services, and this was an old graph where I put unemployment, and essentially what I mean by that is that services is simply a different way of saying unemployment. Anyone who does services, especially if they do internet stuff, well, I don't think they have a job. Okay, that's my take on it. That's not a real job. Again, you're trading labor for salary, for wages. You're not the owner of tangible products. And so I consider that like you're one of the have-nots. But even if we don't look at it that way, if you look at services, what we see in the last few years is that we've changed the labor-intensive services for what we could call self-service, or everybody's an entrepreneur on the internet. Well, in that sense, you are a an entrepreneur, a guy who does it by himself. Maybe you do some investment in the market or in Bitcoin or whatever. So it's no longer you going to the rock pile to the mine and working there, or in a farm or something like that. It's a different type of service. Okay, so the object of the game is to come up with ideas. That's the object of the game. Tell me what services we're going to move on to next. If you cannot imagine it, for sure you're not going to become a millionaire. Okay, you got to imagine it to become a millionaire. Okay, so in a way, hopefully it stimulates your imagination and you become a millionaire. Okay, so let's move on to the subject matter of today, which is Schrodinger's cat. And just to do a little review there, recap, I started a couple of weeks ago talking about the origin of the universe, actually the origin of matter. I'd rather call it origin of matter. It's more precise. And according to mathematical physics, it started with a big bang. Okay, so we started with a big bang, and then we look at the evolution of this matter, because as soon as the Big Bang happened, you didn't have stars and galaxies and atoms. No. According to mathematical physics, that took a process. We started with subatomic particles, such as quarks and so on. That built atoms. From there, we built gases. The gases clustered around, built these galaxies, and within the galaxies, from those same gases, the stars came out. That's the general picture that I covered. Well, from there, I moved on to particles, especially quasi-particles and pseudo-particles, which is simply outrageous. I like to call them quasis, because then you got to be crazy to propose particles that are not particles. Okay, but these are a little more far-fetched than the typical particle that we had with quantum, I guess you could call it classical quantum mechanics, where you have the particle, and then from there we moved on to the pseudo-particle, to the quasi-particle. Okay, and then we looked at some of the properties of these particles, and those are scary. We covered the other day spin, which ain't spin. In other words, they use that word spin, and it's very misleading, because we're not talking about spinning like a top. We're talking about a different kind of spin, which they haven't even been able to define. They don't even know what it is. Okay? But whenever they want to give a physical interpretation, they use the top analogy. They're talking about that spinning like a top. That's not what spin is, not in quantum mechanics. And from there, well, we're moving on today to another property. And just like spin, it kind of is related to this uncertainty principle that Werner Heisenberg came up with in the late 1920s. Okay, so what is this cat? I'll call it a tail, pun intended. The cat tail, Schrodinger's cat tail, his cat in a box. Okay, so this is a summary. So let's start with a summary and end with explaining it, okay, or describing it. Schrodinger's cat is an analogy for a particle. So you have to think of a cat as an analogy, and this is for a particle. Why did he choose a cat? Well, because of what he's going to talk about. But the point is that he's talking about a macro object, an object of our macro world, and a cat obviously is from our macro world. And he's going to turn that more or less, its properties of this cat. He's going to try to explain the properties of a particle with this cat. So he assumed that whenever he says cat, he's talking about a particle. Okay. One of the problems is that so the cat represents a particle. Okay. The so-called particle is merely a probability function. Okay. So this so-called particle is not a particle, not what you think a particle is. It's not a corpuscle or what they call a classical particle. It's not something. It's not something. Period. It's not something. It's nothing. That's what it is. It's an equation. They call that equation a particle. As long as you keep that in the back of your mind, you don't lose track of that, you'll be okay. I won't hurt you. Okay. The particle is described by a wave function. The wave function what? Proposes that a quantum mechanical particle is spread out and occupies all of space. Something a cat can't do. This is a smeared out cat in 3 dimensions. So this poor cat, occupies all of space. Okay? And they call him a particle. When does the cat become a particle? When he condenses into a cat back again. So he has these magical powers that the cat can be a little cat like your cat at home if you have one, right? And as long as you don't look at it or touch it or whatever, it suddenly occupies all of space. It's only when you turn around and suddenly you look at the cat, then the cat turns back into a cat. So you never catch him in that moment when he occupies all of space, okay? But that is the theory, essentially. Okay, this distinguishes the fact that they have this spread out thing. It distinguishes that from a classical corpuscle, okay? Which is, again, the typical particle everybody thinks about, a little ball, a little bead, a little grain of sand. That's what we're talking about when we say classical. Schrodinger put what happens to a micro subatomic particle in macro world terms. In other words, you have to remember that for all practical purposes, what we would say today, Schrodinger was a dissident. He was a dissident from what? He disagreed specifically with Niels Bohr and Werner Heisenberg, which came up with this Copenhagen interpretation of quantum mechanics. And Schrodinger, like Einstein, they were not too fond of that. And so he was trying to make sense of that somehow. And he said, well, I don't know, is that how the subatomic world really behaves, like all these people are saying? And so he was a little bit skeptical. And so he created this analogy, this tail, the cat tail, to try to put it in layman's terms so that people would understand what the mathematicians were doing, what they were saying, what they were proposing for the microscopic world. Okay, so that was his intention. So Schrodinger wants you to understand how absurd, how ridiculous the physical interpretations of quantum mechanics are. Okay, so he wanted you to understand exactly what he's talking about there. Okay, and this is important because you have to remember Schrodinger, he won a Nobel Prize later on because of his equation, which was an important equation, by the way. It essentially mapped what an atom looked like, okay, which was good, what an element, a standard element of the periodic table, what it looked like. You could map it with his equation. That's very fancy stuff. It's really good stuff. But by the 1930s, especially by the time he writes, 1935, when he comes up with his cat tail, cat in a box tail. You have to remember there's this struggle for quantum mechanics. There's the Copenhagen people like Niels Bohr and Werner Heisenberg, and they were saying this is how quantum mechanics actually behaves. That's what we observe in the lab, and this is our conclusion. And you have on the other side people like Einstein and Schrodinger, and they said they were a little skeptical that that's how the microscopic world works. They had no other explanation, no other proposal, but they said, look, there's a lot we still don't understand. It can't be that that's how Mother Nature runs her shop in that secret world of hers. And so Einstein wrote in the same year that Schrodinger writes his cat tail, Einstein writes his EPR paper where he questions whether quantum mechanics is a complete theory. And immediately he got a response from Niels Bohr a few months later in 1936. He got a response from Niels Bohr saying, yeah, we're done. That's it. It doesn't get any better than this. And Schrodinger abandoned physics and started talking about writing books about, philosophy, about how the mind interfaces with quantum and that sort of thing. He got lost in some other stuff. He essentially, got out of physics, like saying there's nothing more to investigate there. I'm done with physics. Okay. Okay, so that's the backdrop or background to what was going on in those days. And here's the exact story as told by Mr. Schrodinger himself. He says, again, he wrote this in 1935, and he says, it is also possible to construct very ridiculous cases. Imagine what he's saying there, okay? Imagine a cat locked up in a room of steel together with a following hellish device, which has to be secured from direct attack by the cat. A tiny amount of radioactive material is placed inside a Geiger counter, so tiny that during 1 hour, perhaps, one of its atoms decays, okay? But also, with equal probability, perhaps none do. In other words, he's talking about radiation, some radioactive element, okay? And so he says, if it does decay, then the counter is triggered, and through a relay activates a little hammer which breaks a flask, glass flask, right, containing hydrocyanic acid, in other words, some poisonous gas. After this system has been left alone for 1 hour, one can say that the cat is still alive, provided no atom has decayed in the meantime. The first decay of an atom would have poisoned the cat. In terms of the psi function of the entire system, this is expressed as a mixture of a living and a dead cat. Okay, so they're talking about probabilities here, okay? It is typical of these cases that in indeterminacy, or again, remember that's the word that Heisenberg used for his uncertainty principle as well, indeterminacy, okay? That an indeterminacy originally restricted to the atomic domain becomes transformed into macroscopic indeterminacy, okay? So that it affects the real world, our world, macro world, okay, which can then be resolved by direct observation. In other words, he says that what you got to do is to verify that that's really what happened, that the atom decayed, is by peeking inside the box somehow. Okay, that's what he's saying. So here's the translation of that. Okay, this is what he's saying. In few words, a cat is placed in a box containing radioactive material in a vessel. Okay, there's an equal probability that in 1 hour one atom will decay or won't. In other words, a radioactive atom, right, shoots some particle out of the atom, okay, spontaneously. The Geiger counter is connected to a hammer that breaks a glass flask containing poisonous gas if decay has taken place. But we don't know if decay has taken place. So the only way to verify whether decay has occurred is by opening the box and checking whether the cat died or not. Then you know that an atom has decayed. Okay? That was the gist of it. Okay, so you get the picture. The picture is we put a cat in a box, and the cat. The only way to verify if there's a decay, if radioactivity has taken place in there, is by opening the box and verifying whether the cat is dead or alive. Until then, he's in this probability world of probability, which is what quantum is all about. It's about probability. It's just equations. And what they're saying is, what is the likely probability of, for example, an electron being here, not there? That's one of the probabilities they look at. That's part of the Schrodinger equation. It's a what they call a wave function. Essentially, it's a spread out thing, covers everything all the way to the edge of space-time. And the particle can be almost anywhere except, for some reason, I never could get an answer to that. It cannot be beyond the surface of an atom. It's got to be within that. It's got to be within what is known as an orbital or an energy level. Okay, those are the terms they use. You would think that particle could go all the way to the edge of the universe. No, it's the wave that goes there. Okay, I guess this wave is spread out anywhere it wants to because the wave has no limit, no boundary. But whenever you look at it, you you try to detect it, measure it, or whatever, it collapses to a point. That's the argument. Yeah, that's the theory. And this is along those same lines. The cat, the only way you're going to know if there's been a decay, you got to look at the cat. Okay? Is it alive or dead? And until then, he's in this world of probability that he could be half dead or half alive, as they say. Or he hasn't chosen whether he's going to collapse to a particle or not. In other words, he's in limbo. He's out there like, you don't know. Really, it says more about what your knowledge is of what's going on inside the box. Okay? So again, people have a little bit of problems trying to understand it in macro terms because you say, well, hold it. Until I peek, isn't the cat either alive or dead in there? He's got to be one or the other, whether I peek or not. Peeking only certifies, whether the cat is dead or alive. That's all it does. But he had to be dead or alive even before that. And that happened when the decay occurred. Okay? The fact that you have no knowledge of what's going on inside the box, that's a separate issue. But, the mathematicians haven't figured that out. Okay, so here's the notion, I guess. This is a way of putting it. This has to do with superposition, meaning that particles can be simultaneously one on top of the other as well as spread out. Okay, and it says that the superposition means, or it implies, that the cat is in all possible states. Okay, so I don't know if there's any other state for a cat to be in other than alive or dead. Maybe he's scratching, maybe he's not, I don't know. But for sure, they're talking about whether he's alive or dead. So it's a black or white. It's a coin toss. It's heads or tails. Okay, that's it. In other words, the cat is both dead and alive before we open the box and peek inside. In mathematical physical terms, right? Math phys, that's what this is all about, right? That cat is a tiny ball and a smeared out wave, both. Because the probability of the cat being both is simultaneous. In other words, he's both a particle and he's a wave. Okay? That's complementarity for you, the complementarity principle. And then conclusions of the mathematical physicists is that subatomic particles behave in strange ways that we don't observe in our macro world. Well, yeah, that's one way of looking at it, and I'll show you a different way of looking at that. Give me a second here, let me pull this up. Okay, just want to point out that this has to do also with Heisenberg's uncertainty principle, okay, and we talked about that the other day just briefly. Heisenberg says that when the ball is standing still, it doesn't move, and when it moves, it doesn't stand still. He made an equation there, and because of that, he got a Nobel Prize, okay. Great for math, terrible for physics, because, yeah, we all know that when you stand still, you don't move, and when you move, you don't stand still. And the more you stand still, the less you move, and the more you move, the less you stand still. Great. I mean, he really deserves a Nobel for that. Okay. Here's the many worlds version that we have today, which is probably the most popular version of the cat in the box tale. Okay, which is that there are many worlds out there, and for every step you take, you branch off into a different universe. There are gazillions, I mean literally gazillions over gazillions of universes out there, and every time you take a step, you branch off into one of these universes. Okay? And you see the illustration at the bottom. Anything that can happen does indeed happen. Okay? So it's not that it can happen, that's not just that it can, it will happen, it does indeed happen. So when you took that step today, you won the lottery, you died, you were alive, you rode a car, you did all these things simultaneously, but every time in a different universe. So you have all these histories out there, okay? So in this universe, the cat is alive, in another one, it is dead, okay? And when you open the box, the world histories split. In other words, what you have is the splitting of all these universes, all these world histories for every action on Earth, for every person on Earth. This is what these people are proposing. Forget about the spirits of traditional religions. That was easy to understand. We can even understand God making the universe. He just takes his magic wand, goes abracadabra, and creates it. We can all imagine and understand that. This you cannot understand. What do you mean? For every step I take, I branch off into a different universe. In this one, I was shot, by a gunman and I died. And the other one, I won the lottery. And the other one, I drove a car. I mean, what is this? This is more than surrealistic. It's just idiocy to the gazillionth power, according to how many universes are out there. What is it? Is this science? Is this really science? Is this what mathematical physics has come down to? And so, yeah, the universe splits and creates copies where all possible outcomes are come true. They are true. And yeah, it's up to you to wonder whether this has anything to do with physics anymore. All I can give you is my conclusions, and here they are. Okay, this is my take on this. I'm saying that Schrodinger came up with thought experiment as a way to argue that this theory did not make any sense. He was essentially laughing at the interpretations of quantum mechanics. He says, look, you can't really put this in macro terms, which, by the way, Bohr and Heisenberg agreed to. He says language is not sufficient to describe this. That's the way they put it. It says we can only describe it mathematically. But then if they can only describe it mathematically and they're only going to provide an idiotic explanation, why do they even attempt to give a physical interpretation to their equations? They should leave it at math, and math only, a description, a mathematical description. We're done. We're okay with that. No problem. They want to describe what they observed, and they want to describe it in terms of point particles. That's fine, but leave it at math. Don't tell me that you've proven the existence of particles, especially particles which aren't particles, even less if they're pseudo-particles or quasi-particles. No, you got to leave it in math. You want to talk math, talk equations. Don't tell me that you know something about the real universe, about the microscopic, subatomic universe, because your equation says something. No, that's your physical interpretation. And if it's idiotic, well, we have to apply Karl Popper. We have to say that, look, falsifiability, I mean, if you believe in Karl Popper's falsifiability, saying that any experiment debunks your theory, if we can show an experiment that shows that your theory cannot even, in this case, not even be imagined, then of course you have to apply Karl Popper in that situation. Not that I do, I don't care about Karl Popper, but the mathematicians, they love Karl Popper, and they love falsifiability. They say experiment debunks theories. Well, here their theory is that the particle can be at two places at once, or that it suddenly converts into a particle. No one can even imagine that. No one can imagine many worlds. And here, this is when they are supposed to be applying Karl Popper, Popperian falsifiability. This is the moment, and they haven't done that. Okay. Instead, instead of accepting the ridiculous explanations, rather than they accept them instead of rejecting the particle hypothesis. I mean, they should erase the board and say, well, no, we can't do this with particles. The problem is particles. If you're going to try to explain, being at two places at once with particles, you're going to have a tough time. And of course, you're going to invent principles like, the uncertainty principles or superposition principles, saying, oh, a particle can be at two places at once or two in one place. You're going to invent all that because you have no way of explaining with particles, especially anything related to action at a distance. Okay? You can't explain tunneling, you cannot explain entanglement, you cannot explain any of those action at a distance phenomena, including, for that matter, gravity and magnetism, which, you can do it with, a couple magnets, as I always do. You got two little magnets there, and there you have it. Okay, so how do you explain this? You're going to use superposition. You're going to use what in between the two magnets? Okay, and gravity is the same thing. So yeah, they cannot explain all this, and you cannot explain it with discrete particles. What they should have done is abandon the particle and apply Popperian falsifiability, which is what they love. Okay, they love Popperian falsifiability. We can call it the falsifiability principle or the Popperian principle. This is where they should apply it. We should reject particles. And if not, then again, they should not try to translate their equations into physics, okay? Because all they have is irrational explanations. Anyways, so my conclusion is that what they have today is no different than religion and traditional religions. In fact, I'd go further and say that traditional religions, are more rational than what these people do. Because we can imagine everything from traditional religions. Everything. We can imagine. The mechanisms are irrational, are supernatural, and the proposals are supernatural. You know, angels, spirits, God, the devil, heaven, all that stuff is supernatural, you know, so we start off on the wrong foot. But we can imagine the mechanism. We can imagine, well, to some degree, we can imagine at least God waving his magic wand and saying abracadabra and creating the universe. Okay, we don't know what the process is from one frame to the other where something appears after nothing was there. Okay, we cannot imagine that, but we can picture what the person is talking about. We cannot imagine one particle being at two places at once. And so again, this is not only like traditional religions, it's much worse. It's much worse than traditional religions because it's totally irrational. You cannot even imagine it. Okay, with that, I'm going to go into questions here. We had quite a few of those. Okay, and so here we go with the first one. Fellow says, explain how these invisible, intangible object double ropes. Okay, we're talking about the rope hypothesis, which is what this channel is about. Okay, we say that light is a rope. Okay, torsion along a rope. Okay, there's a physical mechanism that underlies light, in other words, right? And a physical entity that underlies light. Okay, so he says how these ropes, single thread, produce Chladni patterns, sacred geometry and semantics, especially when you say there is no frequency. I don't know what he's talking about as far as frequency. Of course, there is frequency. Frequency is a trade-off between link length and the number of links. Frequency is number of links. So we say that frequency is there. It's just that we don't call it frequency. We call it link lengths or number of links. Okay. And sacred geometry, that sounds like religion also. So anyone who talks about sacred geometry must be talking about some virgin or God or some nonsense like that. You know, I don't know. What do you mean sacred geometry? Geometry is, you know, like Euclid's geometry, one type of geometry, planes and solids, that's geometry. Nothing sacred about that. So I don't know what this nonsense of sacred is. Maybe some people, these are religious folk. These are people who are religious, fanatic mystics. You know, they invoke the spirits and they talk about sacred geometry. Just to laugh. Okay, when the plate is excited, some areas vibrate and some areas don't move. That's what the Chladni patterns are, okay? More specifically, you are able to see the standing waves along the nodal lines of the plate. The sand moves away from the antinodes, etc., etc. As you can see, he's not explaining anything. And you can read all that later on. You'll find out there's no explanation of the cause, of the mechanism. All this fellow is doing is describing. Okay, keep that in mind. That's what it's about here. Okay, fellow's just describing because, of course, he has no explanation, but he's asking me to explain it. Okay, okay. So what do we have here? Here's this fellow Chladni. Okay, so you know what he's talking about, and so he gave, by the way, a link. So I went to that link, and someone wrote about this fellow. And his name is Ernst Chladni, and he was a fellow who did some experiments in the late 18th century, beginning of the 19th century. Okay, and one of that site starts out with a quote from Nikola Tesla. Okay, And obviously, good old Nick, he was not a very smart guy as far as science was concerned. He was just an inventor, okay, which has nothing to do with science. And he says, if you want to find the secrets of the universe, think in terms of what? Energy, frequency, and vibration. Well, none of those are physical objects. So poor old Nick, yeah, he had no clue. So I want to make sure that we put the correct statement there. If you want to understand a mechanism, think in terms of objects. Okay, that's the only way you're ever going to have a mechanism. Okay, and so we don't care about the secrets of the universe or about sacred geometry, whatever nonsense that is. No, we care about mechanisms. Okay, that's what physics is about. Explain the mechanism. Can we see sound? The fellow who wrote that piece, right, the one that the link was in, said, can we see sound? And he clarifies, not directly, but we can come close. Okay, so first of all, we notice that we will not be able to see sound the way this fellow who wrote about sacred geometry believes, the guy on the left. Okay, he believes that we can see sound. This guy clarifies that up front and says, can we see sound? Not directly, okay, but we can come close. So we don't know what he's talking about. Are we going to look at it with one eye? Are we going to look at it without eyes and just do it by braille or what? What is he talking about? He says, we now know, we know that sound propagates in waves. Again, you can see that's idiot talk. Nobody says that a flag propagates in waves. That's not the way a rational human talks. A rational human says the flag waves. See how simple it was? What do you mean propagates in waves? No such thing. You can say the flag waves, not that it propagates in waves. Anyways, through a solid gas or liquid medium. Chladni paved the way for what? For experimental acoustics. Experimental already shows me that this guy is not going to be doing science. He's going to be doing something about experiments, about something he observed that he cannot explain. And it says he was able to determine sound velocities in gases. Well, that's only a description. I don't care if he can determine sound velocities because that's not an explanation of anything. Okay? And what is he talking about? He's talking about this. Okay? This is what it is. He's going to shake this plate and some sand or whatever on top of it, and he creates all these patterns. Okay? And these are the Chladni patterns. Okay? Okay, so you see them, very nice, very beautiful. A lot of people watch some of these videos. This one had 16 million hits, and the guy had never explained anything. Again, just flashy stuff that he puts on the screen, which other people buy. Probably the people who believe in what? Sacred geometry. They are hypnotized by this stuff, and that's not a single one can explain it. And so we look for an explanation in this guy's site and say, okay, let's see what you can explain. And he says, here's how it works. I said, oh, great, someone's going to explain how it works. It says, when the plate is excited, some areas vibrate and some areas don't move. Okay, so far that's a description. Okay. Then he continues, he says, more specifically, you are able to see the standing waves along the nodal lines of the plate. So far we have a description, no explanation for how it works, what makes these things do what they do. The sand moves away from the antinodes, where the amplitude of the standing wave is maximum, and toward the nodal lines, where the amplitude is minimum, forming patterns known as Chladni figures. Again, description, description, description. All we have so far are description. There is no explanation anywhere in that whole thing. Okay? So far we have no explanation. And you read the link there, the rest of the link of that article, and the guy ends with this, or more or less he continues with this. But this is essentially his punchline, his conclusion. He says, we've seen how the patterns on a Chladni plate are created, but what do they mean? What do you mean how they are created? He never explained anything. We don't know how they are created, meaning explanation. All we know is that there's a vibration, and for some reason, they form these patterns, these nodes, antinodes, and all that stuff. We still don't have an explanation of the mechanism. What's causing the grain to move from here to there? That's what we want to understand. Okay, and we don't have an explanation. And so he says all objects, including Schrodinger plates, have a set of natural frequencies at which they vibrate. Description. That's not an explanation so far, okay? A system such as standing waves in a musical instrument tends to vibrate at certain discrete frequencies called natural frequencies or eigenfrequencies. Again, all this is description. We don't have a single explanation, okay? So the guy, this fellow, he wants an explanation, but like suggesting, we have an explanation, you don't. Well, yes, I do have an explanation, but I'm not going to give. I'm not going to give it because first I'd like to see an explanation for those folks who go out there and put all these vibrations things on the internet all over, both in blogs and in YouTube. I want them to come up with an explanation, physical explanation on what is happening. And for this, they're going to have to use objects, right? They have to explain how some object affects another object. We want to see a mechanism. And until we see a mechanism, there's nothing to address. Okay, all we have is a description, something fancy. It's like saying, look, I can do a magic trick too. I have two magnets and I put them together and they stick. Now, isn't that magic? And I can also pour some iron filings and I can create all these fancy patterns. And they tend to stick towards the center of the magnet. And if they're in the positive area, they get away from the negative area. And, all those are descriptions. I still don't have a mechanism. And so the guy wants an explanation, but he doesn't even know what an explanation is because he thinks he's got some kind of explanation to begin with. Okay, so that's where the problem is. Okay, people don't understand the difference between a description and an explanation. Okay, next one. Paul says, here we use problem with the definition of object. He still thinks that he doesn't like my definition of the object. Can you believe that? The red square is not an object, he says. Okay, the green tree showed near the red square is not an object either. Okay, the object is not an object. 2D objects don't exist. Well, again, it's one of the problems here is first they never tell you what the definition of the word object is. That's the first one. And then the second one is they take for granted that the word exist means exactly the same thing as the word object, which is what we've had for the last 400 years, 500 years, really. Everybody thinks that the word object means the word exist, and everybody thinks that the word exist is exactly a synonym of the word object. An object is that which you can touch or see, three-dimensional, etc., etc., surface to surface. That's the way they see it, because if it doesn't exist, it's not an object. So obviously they say, well, does a square exist? Well, you're talking about something else. You're not talking about the word object. We want to get to the word object before we talk about existence. And these people jump the gun and they say, see, it doesn't exist. We're not talking about existence. We're not talking about existence. And as long as you introduce the word exist in there, you're going to run into trouble. Okay? And so, yeah, the word tree, does the word tree refer to an object? Always. Whether it's the imaginary one, which is the two-dimensional one I drew there or took a picture of, or the real tree I have outside in my garden. Does the word tree, answer the question. Don't change your don't go off on a tangent. Just answer the question. Does the word tree always, here on the other side of the universe, in the land of the Klingons, does the word tree always refer to an object? Okay, that's the question. Okay, and you got to answer that question. For that, you got to define the word object. You got to say what the word object is, and don't confuse it with the word exist. That's how simple it is. Because if you're going to talk about existence, talk about existence. Don't talk about object. First, you got to define the word object, then you can talk about the word existence. Because if you're going to talk about whether an object exists, hopefully you're talking about something different. In other words, the word object is not a synonym of the word existence, first of all. And second, you got to define the word object because you're going to talk about its existence or whether it exists or not. It means that there are objects, you're implying that there are objects that don't exist. And a square is one of those. The square is an object because it has shape. That's the only condition to be an object. Physics doesn't deal with objects that don't exist. Physics deals with objects that do exist. But existence is something different than object. Object is different than the word exist. Okay? Okay, and another fellow also followed up on that, said we may never get through that a square isn't an object. Yeah, if you never define the word object, you're never going to get past it. We're never going to know or understand whether a square is an object because it's up to you to define the word object. And until you define it and can defend your definition, because everybody wants to copy a definition they found somewhere and they say, oh, I found this in a dictionary, I found it in some science book or whatever. No, I don't care where you found it. I don't care if it's your definition or someone else's. I don't care if every person on earth votes for your definition. That's what everybody out there likes to think of as far as an object is concerned. We don't care about any of that. You got to come here and defend your definition if you're going to criticize the definition. You're going to criticize? No problem. Begin by defining the word object, then you can criticize. It's very simple. Define the word object in a way that you can defend it, meaning that you can use it consistently, rationally, and certainly anything related to the word touch, the word see, or three-dimensional, none of those will pass the test. Okay, and if you talk about existence, again, you got to define first the word object. We don't care about existence. Don't use the word exist in any way, shape, or form. Don't tell me whether the fly is on one side of the square or on the other. That's existence. Tell me whether the word square refers to an object. Tell me whether the word tree refers to an object. Tell me if the word energy refers to an object. And if not, to what does it, what category are you going to put it under? And what are these categories? You have to define these categories so that you can put the word energy over here, the word spirit over there, the word angel over there, God over here, tree over here, rock there. You got to be able to put these words under certain categories. Okay? And I'm saying there's only two categories. That's it. All the words in the dictionary fall either under object or concept. Quickly, just very briefly, object that which has shape, concept that which does not have shape. That's not the definition, but that's a good rule of thumb. If it doesn't have shape, the word refers to a concept. And that's why we have to define it. Whereas objects we don't define, we point to them, okay? Because they have shape, no problem. And shape is the only universal property that all objects have. It's a universal property of objects. So here's a rundown of that. Okay, let me put it over here. Okay, and it goes something like this. Don't tell me what an object ain't. Tell me what it is. Define the word object. And don't tell me what everybody believes out there. Don't give me the definition of ordinary speech. Bring in a scientific definition that you can defend, that you can use consistently, and again, that does not involve the word exist. Or the notion of existence in any way, shape, or form. Exist is a separate matter. You must define the word object in such a way that you can use it consistently, which no one has ever done, especially in physics. Okay, don't bring authority, don't bring tradition, don't bring democracy. Don't tell me that everybody voted for it. That's nonsense. We don't care about that. Don't tell me that it's your opinion or that everybody's opinion or the mathematical establishment's opinion. We don't care about that anyways. It's my greatest contribution because it destroys all religions. Once you define the word object, all religions die. Okay, and that's how powerful that definition is. And all the people who complain are religious folk. They're defending some spirituality, something they have hidden inside them. That's why they don't like the definition, because they realize it destroys their religion. That's the only reason that they oppose it. And again, all they do is say what an object ain't. They never tell you what it is. And when you realize that they only criticize, they say that's not what an object is, you know that they're religious people. They're fanatic spiritualists. Otherwise, they would define it. It would be very simple. They would say, no, Bill, this is the definition of the word object. And so now we can get into a debate because I can criticize his definition. He can say, well, and he can defend it. He can say, no, this is why my definition is correct. That's the way it works in science. Now you have a scientific debate. But to say, I don't like your definition, everybody out there voted for my definition, this is the one I found in the dictionary, you're a religious fanatic. No, here we do science, not religion, okay? Don't do spirituality, don't bring sacred geometry here, okay? We don't care about sacred. Nothing sacred here, okay? Okay, all dictionary words fall under two categories: religious folk, philosophers, mathematical physicists, and so on. They invent subcategories to get around this. Okay, and what they do, they introduce adjectives. So they start qualifying the nouns. They say black cat, no longer a cat, now it's a black cat. And likewise, they say, why? Because they don't have a clear-cut definition. Okay, and so they have to create all these subcategories to be able to fit their religion within them. So they say, well, they might say that, square is an object, but it's an object that doesn't exist. Yeah, that's a separate issue. An inexistent object. Yeah, I don't care that. Get rid of the adjective. Just put the word there. Tell me if a square is an object. Don't tell me whether it exists or not. Don't tell me whether plasma is an object, because the word plasma means ionized gas, and that means that you've got an adjective, ionized, right, in front of that word. I don't need the word ionized. Is plasma equal to gas? Yes or no? If it's not, then don't tell me that plasma is a physical object. It's not. Gas is an object. Ionized plasma means that you did something to the gas. You ionized it. Okay? So, yeah, you got to be careful about that. Plasma is not a physical object, not a standalone object. You won't see it in a single frame. You can't take a snapshot of plasma, because whatever you took a picture of is standing still. And that's not plasma. Plasma is always in motion. Plasma is always ionizing. Otherwise, it's not plasma by definition, pursuant to the definition. And so what these people do, they want to do physics by moving concepts around. Okay, and they have these words like ether, field, wave, plasma, vortex, energy, electricity, information. They use all these as physical objects. Okay, and that's why they end up with irrational physical interpretations, because what they're doing is moving concepts around. And they don't even realize that. They think that these words like field and ether are physical objects. They're not. Okay? They're always in motion. There's no such thing as a field standing still. Field is a bunch of numbers from a given point of view, and numbers is counting. Okay, so you have motion everywhere there. One fellow says, "You're my favorite atheist." Oh man, no, I've talked about this in the past. I'm not an atheist. Okay, I used to be. I came from a militant atheist family. We were militant atheists. We were one of the first members of American Atheists when it was founded by Madalyn Murray O'Hair. We used to live in Baltimore near her house, and my mother especially, but both my parents, they became friends with Madalyn Murray O'Hair. For those of you who don't know her, she was the founder of American Atheists. She was murdered later on in her life, okay? And a couple times she came to our house. And so, I started out being in an atheist home. We used to talk about religion almost daily. And I read the Bible 3 times by the age of 15, 16, completely from beginning to end. A book that I love, by the way, not because of religious stuff, but I don't care about any of that, but because it's a book that tells you about how people thought thousands of years ago. So it's a historical book. It's a very important book. Even though you'll see a lot of nonsense in there, even that nonsense is important because it shows how people were thinking in those days, 2,000, 3,000, 4,000 years ago, what was important to them. Having kids, spreading your seed, building an empire, all these things that all these farmers, these shepherds were talking about, falling in love, having women, and so on. This is how they thought. And so in that sense, at least the Old Testament is very important. Obviously the New Testament as well, but it's more religious, more spiritual. I don't care too much about the New Testament. I care more about the Old Testament. I come from an atheist background, but about 20, 25 years ago, I started drifting away from atheism because I realized that, what is it? Atheism is the religion of mathematical physics, okay? Of the mathematicians. Why? Because it misconceived the scientific method. They think they're doing science and they're not. They're into belief and opinion, and that's the problem. And so, I let's see if I have it here. No, I don't. I put it in a category of what I call religion. Why? Because anything related to opinion has to do with religion. And that's what an atheist is. An atheist is a person who tells you he doesn't believe, or he knows for sure that God doesn't exist. And that's not a scientific statement. Okay? The way we say it in science is, let us assume God exists. That's a hypothesis. Known as a hypothesis, it means you're going to make an assumption because God is not a theory. You don't believe in God. You don't disbelieve in God. What you do is you make an assumption about God, the existence of God. You say this object called God exists, has location in the universe somewhere, has distance with respect to me, and he created the universe, for example, theory. Or he created that flower, he made the curtain move, whatever, I don't care. So that's the way we treat it in science. Science, you make an assumption about the existence of something like God. We don't say we believe in God, we don't say we don't disbelieve in God, or maybe God exists, but I don't know, and maybe I'll prove it with an experiment. We don't do any of that. We make an assumption. Let me assume, allow me to assume, I'm going to make an assumption that God exists. That's the way it works. And then you explain your theory based on that assumption. That's science. That's the scientific method, not what the mathematicians do, saying, oh, we've proven this. The particle can be at two places at once. We can't imagine it, but we've proven it. Here's the equation. That's not science. That's religion. The worst kind of religion. Okay, another issue. Fellow says, if light is always directly between atoms, then no matter how far away something is, we see it where it really is. Only the brightness and color are delayed by speed of torque, referring to the rope. No, I'm going to take exception to that. Okay, here's a little picture of what this gentleman is saying. Here it is. The question is whether a wave from the Andromeda galaxy extends all the way to Earth, or whether it sails like a sailboat, like a little sailboat from Andromeda over here. Is that it extend or travel? That's the question. In that case, the question is whether, this little sailboat has a beginning and an end. Is it just like that? Just little sailboats coming to us? So where does that little wave begin? Where does it end? Does it extend or travel? That's the question. And with a rope model, you can explain that very easily, because the rope simply extends, from Andromeda to us. Okay, and I think I see it here. Let me wait for a second here and see if I can see the rope there. I think I put it in there. Maybe not. Give me a second, see if it comes out after this. No, I guess not. I had another one, and unfortunately I didn't put that one up there, but essentially there's one where a rope is connected from an atom in the Andromeda galaxy all the way to your eye, all the way to the Earth. And all we have is a torsion. And of course, that torsion is not instantaneous. It does that thump that gets to the atom in your eye is not instantaneous. Once the atom in the Andromeda galaxy does its quantum jump, it expands and contracts, torques the rope, that takes time to get here. 2.5 million years. So it's not instantaneous. So no, in that sense, Einstein was right. We see objects not where they were now, but where they were if it's very far away, like Andromeda galaxy. We see them like they were millions of years ago, a couple million years ago. Okay, so no, it's not instantaneous. The torsion on a rope is not instantaneous. That's what I mean. It takes time for that thing to torque all the way from Andromeda all the way to us. It's fast, 300,000 kilometers per second, but it's not instantaneous. It's not like, here's the blip and here we see it. No, it takes time. Torsion is not instantaneous, but it's for practical purposes. You take a rope, you connect it between two poles, and like I said, you put two clothespins, you move one, the other one moves instantaneously in our macro world. You would have to be a great distance to notice that there is that the torsion is not instantaneous, that the other one doesn't move instantaneously. It takes time for that thing to get there. Okay, so no, torsion is not instantaneous. Just want to clarify my point of view on that. Okay, people can believe whatever they want, but that's my take. Okay, here's another fellow. He says, I'm really interested to understand how do you understand the relationship between mind, thoughts, and reality, and the process of obtaining knowledge and proving some statement as true, etc., etc., etc. He goes into knowledge, knowledge, and knowledge. Okay, one of the problems here is the word knowledge. What does this have to do with science? And again, it's because we have the wrong scientific method. And it's what I was talking about a minute ago with this other fellow who said whether I'm an atheist or thought that I was an atheist. No, all this belongs in religion. There you see the word knowledge. Where do you see it? Under religion. Proof, under religion. Okay? Experiments, sensations, perception, anything of that is opinion. Okay? What do we use experiments for? To convince people, to persuade. Okay? It's to believe, to test their belief, to change their beliefs, to change their opinions. That's why we do experiments. An experiment is not an explanation of anything. Okay? Science, on the left-hand side, it's a rational explanation. So no, we do not do experiments in science. That's in mathematical physics, in religion. Okay, mathematical physics is an irrational religion. Why? Because they do experiments, they do equations. So far we have a description and observation, and then they say we've proven it. And here's the proof. And what they're trying to shove down your throat is their physical interpretation, which they acknowledge is irrational, that you cannot even imagine it, but they've proven it. So what are we talking about? Well, we're talking about, persuasion. We're talking about proving. We're talking about convincing, recruiting. We're not talking about objectivity. We're not talking about explaining something mechanically so that you can understand it. You just want to understand it. You don't want to, it's not about belief or opinion. Whether you believe it or not is your personal problem. What you want to do is understand it. That's science. That's where science stops, understanding. What continues is belief, and that's religion. Same thing with atheism. Saying that you believe or don't believe in God, or whether you know that God exists or not, that's religion. That's religion because all you said is your opinion. We don't care about your opinion. We want you to explain something. And for that, you can say, let us assume God exists, and then you can explain it with using God as the assumption. That's the way it works in science. That's why atheism is nonsense. That's why I had to abandon atheism. Atheism is the religion of mathematical physics because mathematical physics clings to an old-fashioned scientific method that we inherited from the people from the 17th century. It's a 400-year-old scientific method which has nothing at all about scientific. I call it the religious method. Okay? It's about belief. Okay, another fellow said, I would love to hear you talk about virology. Is virology science? If so, is it physics or philosophy? Do viruses exist or are they concepts? Okay, I think it's a valid question to address. First, I'll say that I'm not a doctor, so I'm no specialist in viruses. All I can do is give you my 5 cents worth. This is back of the napkin type of stuff that I'm going to talk about here. Okay, here it is. In a nutshell, okay, this is simply out of the top of my head. Here's the description of a virus. It's a complex molecule, consists of DNA, RNA, encapsulated within protein membrane and much smaller than a bacteria. Okay, what does it do? Well, it's an inert parasite, you could call it. Okay, it's not alive, it's dead. Okay, it's a molecule. Okay, that's all it is, complex molecule. But I call it an inert parasite because it's like a stone that you have in there, but this is a special type of stone. It tends to penetrate the cell walls of the cells in your body, and it makes copies of itself using the cell material. Okay, that's my 5 cents worth on what a virus is. Is it a theory? Is it part of science? Is it part of philosophy? Well, it's a theory. Okay, in other words, the virus is the object. Okay, and they say it's a molecule. The molecule penetrates the cell and makes copies of itself. Well, DNA makes copies of itself, and DNA is also a molecule. are we going to say that DNA is irrational? Well, I think DNA is a good explanation. Okay, it's a good explanation. I like it. Partly because I understand it. I'm not an expert in this field, but I do like it because I understand it. Someone shows me a picture of DNA trolling around, saying, just twirling on its axis and making copies of itself, and I say, okay, I understand what's happening there. So to me, it's rational because I can understand it. They can make a movie it and show you what's happening. And with a virus, the same thing. It's this thingy, inert thingy. It penetrates the walls of a cell. Okay? Takes the cell material, which is also CHON, Chan, as I call it, right? And it makes copies of itself. And by making copies of itself, it becomes a parasite. And it should be there. It's something you have that's artificial inside your body, making more and more copies of itself. Yeah, it's got to cause problems in that region and kill you, if it gets too far. So I understand the theory, and I understand what the people who propose viruses are telling me. So as long as I understand it, I have no objection to it. And I don't have an alternative theory because I don't care about that world at all. I don't care about medicine or any of that stuff. So for me, it's good until someone comes with a better mousetrap and tells me, look, there's this other theory here. And again, people should not tell me what it ain't. Don't tell me that a virus ain't. I don't care about that. And all the arguments against viruses, I don't want to hear that. I want to hear what you propose in its stead. What is your theory for diseases or for whatever? And in that sense, yeah, viruses, as far as I'm concerned, are part of science because it's objective. I can understand it. They can make a movie of their theory. And until I see another theory that competes against it, it's not that I believe in it, but what I do is I use that same material when I have to explain something. I say, look, this is a virus and enters the cell and makes copies of itself. And the person said, do you believe in that? Well, I'm just going to use that as an assumption for whatever I'm going to talk about. That's it. That's science. Science is not about belief. Science is about this theory is rational, makes sense to me, and I'm going to use it for something. And again, tomorrow someone comes up with a better theory, well, I might switch them over. I don't know. Got to wait for that day. But yeah, as far as I'm concerned, it's more or less like evolution. Is evolution a theory, or is evolution proof? Has it been proven? Is it a fact? No, evolution's not a fact any more than anything else is a fact in science. In science. In religion, it's a fact. In science, evolution is a theory. It's known as a theory. What is a theory? It's an explanation. The guy says, look, we weren't born like this, like it says in the Bible, which is another theory. We had this process, this lengthy process in which something changed into something else over time and eventually came to be what we are today. And to me, the whole cycle makes sense. To me, I can visualize it, I can picture it. I can even, like I showed in one of my videos, I can see the intermediate missing links here and there. We're talking about millions of years, so you can't get all the missing links, but you can see some of the missing links, okay? Like, how life could have started. I put that in my book. And so again, these are theories. These are explanations so that you visualize them, understand them, and that's where science stops. Whether you believe that that's exactly what happened, well, that's your personal opinion. It doesn't concern science at all. Science only stops at mechanisms and show me the process, how we came to be, and I like the evolution theory. No, it's not a fact. It's a theory. It's an explanation. That's all it is, objective explanation. The explanation from traditional religion, Christianity, God made the universe. Well, yeah, it's an explanation. For me, it's an irrational explanation because, first of all, I cannot conceive of this something from nothing. Okay, turning something from nothing. Turning empty space into a matter, into an atom. I don't know what the process is there. If they can explain that process, then maybe I'll start accepting it. Maybe I'll start using that theory as well as an assumption. Until they can show me that process, I have nothing to borrow from traditional religion. Okay? It's just nonsense. Okay? Because they cannot explain a mechanism. I need the mechanism. I don't want you to tell me you believe because the Bible says. That's authority. That's nonsense. That's idiocy. Okay? And that's exactly the word that you got to use, idiocy. Okay? Now, the way it works in science, you got to say, look, this is the mechanism. This is the process. I can make a movie of it so that you can understand it by just watching the movie. And that's what evolution is, and that's what viruses are. Okay? You can watch the movie and understand it. You understand it, we're done. You believe in it, we don't care. Okay, another comment here. Moving on. Why should all other mammals become extinct with us? One fellow says. Okay, all I'm going to say is that, you know, when the dinosaurs died, as far as the record shows, like what they see in the rock, they say that all animals, and I don't know if all animals, but what they see is that the only thing that more or less survived are animals the size of a cat or smaller, maybe the size of a chicken. Okay, that's it. That's all that survived. Anything that was big was wiped out. Okay, and I think the reason for that is that the big guys ate the little guys at the last moment. They ate whatever they so found. So you got a T-Rex who's used to eating, I don't know, triceratopses, and suddenly they're not around or he can't find some, and he's going to go after the smaller game. He's going to eat potato chips. And so he's going to eat anything that he can catch and see. If it's too little, it's not worth his energy. Okay, so the way I look at it, when we leave, we're going to wipe out every mammal in town. And we don't eat, usually we don't eat ants, and we don't eat, other stuff like that, even though I think those are going to disappear as well, a lot of those. But for sure, any animal that is big in the forest, wolves, bears, buffalo, that's all going to be wiped out. We're going to kill them the first day. Those are going to be wiped out within the first few weeks. And then after that, there's nothing left for you to hunt out there in the wild, because everybody's going to go out there with their bow and arrows, with their guns, whatever they have on their hands. They're going to start hunting whatever's moving out there. And then they're going to start hunting hunters. Okay? That's the way it works. That's why, I like to laugh at these folks. I've got a saying here, and it goes like this. Survivalist without a cause is a hunter, and prepper without a cause is a gardener. Okay? Because you have all these survivalists and preppers, they're preparing, and you say, what are you preparing for? And they say, well, I don't know, maybe there could be a flood or a forest fire or whatever. Is that what they're preparing for? And if we're preparing for the end of the world, whichever way it comes, I don't care. And maybe a lot of these people are thinking nuclear weapons. We throw the nukes at each other, and so head for the hills. And so here's the survivalist. He's going with his backpack, his gun. He's going to live out on the wild forever, And it turns out the first thing that's going to be wiped out is everything that he wants to hunt. First thing that goes is wild animals, because everybody's going to go out to the forest and just catch whatever they can if they're hungry. Everybody who lives near a forest or even farther away, they're just going to drive down there and say, well, I'm going to hunt something. I'm going to hunt a bear if necessary and cook them over a week. So they're going to be killing animals. And besides that, everybody's going to be killing each other. And I don't know how much you can live off of hunting animals, especially when they need to eat as well. When a lot of people go out there and hunt animals, they're just going to wipe out the forests and the jungles. That's why people say, well, how about those lost tribes? Well, there are no lost tribes. We found them all. We've got satellites. We can see a matchbox on the floor from the sky. Okay? So there are no lost tribes, as some people believe, still out there. We found them all. We know where they are. And in fact, a lot of them, all of them, 100% of them are protected by governments. Okay, there was this island in the middle of the Indian Ocean there, between India and the Indonesian peninsula there, and the Indian government has to protect these people, because otherwise people would just go in there, missionaries especially with their Bibles, and try to convert them. And it turns out the Indians kill the natives. They kill these missionaries, and so the government said, "Don't go there. We want to keep them like they are. Let them." evolve or whatever, So the government's protecting them. The day the government is no more, who's going to protect those natives? They're just going to go in there and kill them all. They're going to hunt people. So this notion that, when the world collapses, we're all going to be friendly and teaching each other how to farm. I really laugh at that. People are really suckers for that kind of thing. They think really they're, in a Nashville jungle, we're going to have friends and families and, families maybe, but friends, neighbors, they'll become enemies overnight. Okay, so don't trust anyone. No one trusts anyone in the asphalt jungle once the economy collapses. Nothing to trade, you got to steal, you got to kill, no other way. And that's what's going to happen. Nobody claims gravitational waves are responsible for gravitational attraction, least of all Einstein, who considered gravity a geometric phenomenon of curved space-time. Claims made about gravitational waves involve the ability to move beads along a rod and note a resulting temperature increase. Okay, let's find out. Well, here, let's look up first the definition of what a gravitational wave is. Okay. So here it is. Here's a gravitational wave, and this is out of the wiki. It says gravitational waves transport energy, whatever that is, okay, as gravitational radiation, whatever that is. What is radiation? What is energy? A form of radiant energy, similar to electromagnetic radiation, whatever that is. Okay, and there you see a picture on the bottom. These are gravitational waves from some mass that moved. So some object moved out there in space. They call the object a mass. They say that space is made of this stuff called space-time, and some kind of medium, continuous medium. And so whatever moves or shakes that space-time thingy, canvas, three-dimensional fishnet, whatever you want to call it, that wave moves everywhere, including to here on Earth. And so then what is the purpose of a gravitational wave if it doesn't do anything related to gravity? Gravity pulls. I mean, the Earth would fly out of the solar system if it weren't that the sun somehow keeps it there. Okay, and we say, well, it's gravity. And in the case of space-time, we talk about warped space. We say that the canvas is warped. Okay, and that's why the Earth cannot go outside that wall of time that prevents the Earth physically from going out. Whatever that means, because that's what these people are saying. They're saying there's a depression of space-time. Time is warped, it forms a circle, and the Earth orbits around that circle like the little ball around the roulette, okay? And what comes up against the skin of the Earth is warped time. That is the explanation. So what role does a gravitational wave play in that scenario? That's the question. And so here we see a little something of that, a little illustration of that. And it goes something like this. You see the two mechanisms for why the Earth, according to relativity, why the Earth would fly out instantaneously out of the solar system. Not according to relativity, according to Newton. The Earth would fly out of the solar system instantaneously according to the equation, Newton's equation. If the sun happened to disappear, there is no mass. You have mass divided by distance squared. One of those masses is now zero. It's gone. So the question is, according to Newton, the Earth, which is the top picture on the right, would fly out of the solar system instantaneously as soon as the sun evaporates. So here you see it evaporate here in a second. There it goes, bloop, and the Earth flies out instantaneously. Why? Because the mass is not there. That's Newton's theory. That's Newton's equation. What's on the bottom? Well, the relativity version. What you see on the bottom is that the sun is going to disappear. Here you'll see it in a second. It evaporates, but the Earth continues rolling around the sun until the gravitational wave reaches the Earth, and the gravitational wave cannot travel faster than light. At most, it travels exactly at the speed of light. And we got a problem with that because that is irrational. They're saying that the mass called the Earth is revolving or orbiting the mass called the sun, even though there is no sun anymore. And they say, well, the signal cannot travel faster than light from the sun to the Earth, so the Earth would not find out gravitationally that the sun has gone. That's the argument. And so we have a problem there because the question is, what is the role of that gravity wave? I mean, if there's no sun and here's the gravitational wave still going, what does the gravitational wave do? Does it, while the sun is still there, does it pull on the Earth? What is the purpose of a gravitational wave? Why did they put the word gravitational in front of the word wave if that wave is not going to do gravity? And if it is going to do gravity, then yes, I'm right. What these people are trying to tell you is that the gravitational wave pulls on the Earth. Otherwise, it has no purpose. What is the purpose of a gravitational wave if it doesn't do gravity? Why did they put that adjective in front of it, calling it gravitational? Okay, so that's the issue. And so, yeah, you got to tell me what a gravitational wave does. And this fellow says it just throws energy or radiation or whatever. So what's that radiation for? Why do we call it gravitational wave? I mean, that sounds like electromagnetic wave. That also brings radiation to your eye or light or whatever you want to call it, energy. So in what way is a gravitational wave different from an electromagnetic wave? If we would think that if they put the word gravitational in, it has to do something with a pull of gravity. But if it's not going to pull, if it's just going to reach the Earth and the Earth is just like light and just notify us that the sun is no more, then that sounds like light. Doesn't sound like gravity at all. So again, what is the purpose of the so-called gravitational wave? Okay, final question or comment that a person made, and he says, he held up, meaning me, Bill held up a disc, once again calling it a circle. He's saying that, do I have one? Oh, let's see if I can get it. I showed something like this, okay? I hope that's not too bright. Let me turn it around. Same brightness, okay. I showed something like this. I'm saying that this is a circle, okay? A roundish thing. Flat Earth. Circle. And this guy says, he shows this and he says that's a circle. That's not a circle. Too lengthy an answer. So what I'm going to do, I'm going to put it as the subject matter of Wednesday, because apparently people don't have the slightest idea what a circle is, what a square is, what a triangle is. We got to get these people up to speed with basic geometry. Okay, they need to learn the ABCs of geometry. They need to learn kindergarten geometry. Right now, these folks have no idea what a circle is. And so that'll be the subject matter of on Wednesday, next time. We'll see you then. Bye-bye.